welcome to the video lecture series of operating system. In today's session, we are continuing with the topic memory management. Myself, Krunal Panchal, your instructor. In today's session, we are going to discuss variable size partitioning. Variable size partitioning in detail with the help of example. So in the previous session, we have discussed the contiguous memory allocation, in which there are two types. One is fixed size partitioning policy and second one is variable size partitioning policy. So in the previous session, we have discussed the fixed size and variable size partitioning scheme in conceptual way. Now, in this particular session, we are going to discuss variable size partitioning scheme with the help of example. Okay, and its algorithms. So, before going to discuss variable size partitioning scheme with its algorithms, so you need to recall the working of variable size partitioning scheme. So what was the scenario in the case of variable size partitioning scheme? So in this particular scheme, there was no prior partition. There was no fixed size partition. Okay, size of the partition was not fixed priorly. So that was the scenario of variable size partitioning scheme that we understood in the previous session. Okay, now let us take on those scenarios of variable size partitioning in this particular session and discuss the various algorithm of variable size partitioning scheme. The same type of algorithms are available in the fixed size partitioning scheme as well. But before going to discuss the algorithms of fixed size partitioning scheme, let us discuss the algorithms of variable size partitioning scheme first. Okay, then we'll discuss the same algorithm with the help of fixed size partitioning scheme, or we say in the context of fixed size partitioning scheme. So, in the case of variable size partitioning scheme, it has three main type of algorithm. One is first fit, second one is based fit, and third one is worst fit. So, these three algorithms we need to discuss with the help of one example. So, these three algorithms we will discuss in the case of fixed size partitioning scheme as well, but that we will see in the later session. In this particular session, we are going to discuss these three algorithms with respect to variable size partitioning scheme only. So let us discuss these algorithms with the help of one example. So in the case of variable size partitioning scheme, as I told you, there is no prior partition. So you can see in this particular figure, there is a different size of memory block we have. So you people might confused. Sir, you told us in previous session, as far as variable size partitioning scheme, there is no prior partition. So the answer of this question is what? Yes, you are true. There is no prior partition in the case of variable size partitioning scheme. But this particular figure, or we can say snapshot, we have taken at a particular moment of time. Okay, so this is not the initial scenario of the memory block. This is the scenario of a particular time that we have taken. Okay, so at that time the scenario of the different blocks in memory is look like this. So in which there are two types of block. One is red block and second one is blue block. So there is no significance of this color. Okay, just to differentiate which blocks are available and which blocks are already occupied. So that is the reason why I have used the different color. The blocks which are in red color, that blocks are already occupied. So that blocks are not available to satisfy the upcoming request. Yeah. So block number 50, block number 300. It is not a block number, we can say. The block which requires 50 size, the block which requires 300 KB size, the block which requires 600 KB size, which is represented in red color, are already occupied. So what are the available blocks we have? The block which has 150 KB size, and the another one is the block which contains 350 KB size. So these two blue blocks are available to satisfy the upcoming request. Okay, so now we are going to have the different type of request in terms of size as far as different processes are concerned. So let us discuss these P1, P2, and P3 and P4. These four processes have a different request, different size of request, we can say, in sequential order. Means P1 requires 300 KB of size, P2 requires 25 KB of size, P3 requires 125 KB of size, and P4 requires 50 KB of size. So these 300, 25, 125 and 50 respectively, this request needs to be accommodated into the available block of memory in this particular figure. So these are the different processes which arrived in a particular order, in which P1 came first and P4 was recently came into the existence. So let us discuss the first algorithm, which is nothing but first fit with respect to variable size partitioning scheme. So what is the scenario of first fit? So first fit algorithm works in this particular way, in which it will simply start scanning from the initial position and go towards the first block which is available and which is sufficient to accommodate or hold the requested process. That block would be assigned to that particular process. So how first fit works? It will not scan all the available blocks in the memory. Rather than scanning all the available blocks in the memory, it will simply start searching from the initial position and it will look the first available block and it will check by having this first available block, can we satisfy or can we hold this requested process? If the answer is yes, it will simply assign that process to that particular block. If the answer is no, in that case it will search to the next available block of memory. Again it will check whether it is capable enough or not. In this way it will work. So it will not scan all the available blocks priorly. Here, so when P1 requested for 300 KB of size, so what first fit algorithm will do? In this case, it will start searching from initial position and the first block which is already occupied, size of 50 kb, it is already occupied. Yes, second block is available. So size of second block is what? 150. So out of 150, the requested process size is 300. So this requested size is larger than this. So again, in this case, the first field algorithm will skip that block, and again it will start its journey to find out the capable enough block, okay, in upcoming blocks. So the next block is 300, but it is already occupied. Yes, it is capable enough, but it is already occupied. So skip that stuff. Again, it will go to the fourth block. Fourth block size is what? 350. So 350 means what? 350 is capable enough? Yes, it is capable enough. So what will happen? The P1 process will be accommodated to this particular block by the first fit algorithm. Now, once it is accommodated, now what is the remaining size of that block? Because we are talking about variable size partitioning scheme, in this case, the partition can be further partitioned, or we can say a single partition may have two different processes. So the remaining partition can be reused in the case of variable size partitioning scheme that we understood already in the previous session. Yes. So once the P1 is accommodated in this particular block, now what is the remaining size of this block? That is nothing but 50 kb. Now this 50 kb can be further reused. Okay. Now the next request came, which is nothing but P2. P2 requires 25 kb of size. So what will happen again? Again, first fit algorithm will start its journey from the initial position. Again, it will start searching the first capable enough block. Okay. And in this case, again, it will find the 150 size of block, and 150 size of block is capable enough to accommodate P2 process. It will simply accommodate it. And what is the remaining size of that block? 150 minus 25 is equal to 125. So 125 space is further utilized by the first fit algorithm because we are dealing with variable size partitioning scheme. Okay. Now the next request scheme, P3 is equal to 125. 125. Again, first fit algorithm will start its searching from the starting point, and it will start searching. The next block is available. What the size of that block is what? Luckily, we have the same size of block available in the second slot. So 125 is equal to 125 means what? The requested process size is equal to the available size in the case of second slot. Yes, so 125 P3 process can easily accommodate in that particular partition. Okay, now the P4 came. P4 requires 50 kb. So can we have 50 kb? Again, first fit algorithm will start its journey from starting point. It will try to scan the capable enough block, and it will go to the second last partition in which we have 50 kb left. Yes, and luckily we have the same size of request in this case. So we can easily accommodate P4 process in the second last slot. Clear? So in this way, first fit algorithm works. Now the next one is based fit algorithm. What it means and how it works. Based means in the case of variable size partitioning scheme in which the partition can be further reused. So how based fit algorithm will work? So instead of accommodating first capable enough block, how based fit algorithm will work? It will initially, when any request arrives, it will initially scan all the available blocks size, and according to the available block size, it will accommodate that process by considering the smallest enough block which is available in that whole slot. In this way it will work. So suppose by considering the same request P1, P2, P3 and P4 in the case of waste feed algorithm as well. So P1 requires 300 KB. So how waste feed will work? So once P1 arrived, waste feed will scan all the available memory slots. So how many slots are available? 2 slots are available. Yes, one is 150 and second one is 350. So which one is capable enough? Second one, 350 block is capable enough to accommodate the process P1. So P1 would be accommodated over there. Yes. Now what is the remaining size? 50. So 50 KB can be further utilized. Yes. Now the second request came, P2. P2 require 25 KB. So in this case what will happen? Now in this case scenario will be changed. Because waste feed, as I told you, it will find out the smallest enough capable block to accommodate the process. Okay. So in this case, again we have 2 slots. One is the size of 150 KB and the second one is the remaining block. It was 50 KB. So 50 KB is the smallest as compared to 150 KB block. So P2 would be accommodated in 50 KB block instead of 150. This is the change with respect to first feed algorithm. Yes. So out of 50, the 25 KB would be accommodated to P2 process and remaining space 25 KB still can be further utilized for the upcoming process. Okay. Now the third request is P3. P3 require 125 KB. So again it will check, yes, 150 KB of block is capable enough to accommodate that process. So 125 can be easily accommodated in 150 block. Now the remaining size or block is nothing but the size of 25 KB. Okay. So now till now what is the scenario? Now we have 25 KB of block in second slot and 25 KB of block in the second last slot. So total we have 50 KB, but this 50 KB is not available in contiguous fashion because we are talking about contiguous memory allocation where the process is requested. So when process will be executed in the CPU, where the whole process will be picked from the secondary memory and put it into a main memory if it is available in contiguous fashion only. But in this case 25 KB and 25 KB is equal to 50 KB, but this 50 KB of size is available into non-contiguous fashion. So now say for example last process came 50, it requires 50 KB of size. Yes, we have 50 KB of size available in the memory block, but what will happen in this case? This 50 KB of size is not available, it is scattered, it is available in scattered fashion, it is not available in contiguous fashion. So that is the reason why P4 request cannot be satisfied in this case. Yes, so the name implies waste feed. Waste feed should work best, but in this case it performed worst. Why? Because of its nature. Because we are using this algorithm in variable size partitioning scheme. So you need to keep this in your mind. The waste feed algorithm perform worst in the case of variable size partitioning scheme, but when we discuss fixed size partitioning scheme with respect to base feed algorithm, base feed perform best. Later on we will see in the next session. Okay, that things to keep in your mind. But in this case, base feed perform worst in the case of variable size partitioning scheme. Okay. Now Now the last one is worst fit. The same like best fit scenario, but with only one change. In the case of best fit, it will search all the available blocks priorly, and according to that it will find out the smallest enough block and accommodate the request. Yes. But in the case of worst fit scenario, again same like best fit, it will scan all the available blocks priorly, and the block which is not smallest enough, in this case the block which is largest enough to accommodate that request, that block would be picked to hold that request for its execution. So what will happen in the case of worst fit? So again, if P1 arrived which requires 300 KB, so we have two blocks available, one is 150 KB and one is 350 KB. Obviously the 300 KB size is accommodated in 350 because we have only one choice. Yes. So the P1 will hold in the second last block, okay, in the memory. Now what is the remaining size? Remaining size is 50 KB, and 50 KB can be further used. Okay. Now P2 arrived. P2 require 25 KB of size. So again we have two blocks. We have two choices. One is 50 KB of choice and one is 150 KB of choice. Which one is largest enough to accommodate this request? 150 KB of block. So 150 KB of block will be provided for P2. And what is the remaining size? 150 minus 25. 150 minus 25 is nothing but 125. So 125 can be further used. Okay. When P3 arrives, P3 requires 125 exactly. Yes. So the same size of block we have in the case of second slot. So 125 can be easily accommodated second block of memory. So P3 is accommodated in 125. Now P4 requires 50 KB. So luckily we have a 50 KB of block is available in second last slot. So P4 can be easily accommodated. So in this way, the first fit, base fit, and worst fit algorithm works in the case of variable size partitioning scheme. So the conclusion of the story is what? The base fit algorithm performs worst in the case of variable size partitioning scheme. Why? Because we are considering the smallest capable block to accommodate the request first. So that is the first priority. So by having this nature, what will happen? Once you accommodate these smallest capable enough a block to hold that process, the remaining size of that block would be very less, and there are less possibility, or this is very less probability to reuse that space because that size is very small, to reuse that space for upcoming processes. That is the reason why the wastage of memory would be higher. That's why this will perform worst in the case of variable size partitioning scheme, and worst fit algorithm perform best in the case of variable size partitioning scheme. Why? Because it gives priority to a largest capable enough block, so that once the process is accommodated, the remaining size of that block would be higher as compared to base fit algorithm. So we can easily accommodate upcoming processes within that remaining size of block. So that's why worst fit algorithm perform best in the case of variable size partitioning scheme. So I hope it was clear to you. Thanks for watching this video. See you in the next one.